Hello everyone, welcome back to the lecture. So in this lecture, this is my part number 5, where I'll be explaining about the slab reinforcement. Okay, yeah. This is part number 4, where I'll be explaining about the slab reinforcement. Already I've made part 1, part 2, part 3. Go and watch it and then come to the part 4. So this is how the slab reinforcement details will look when you look at the structural drawings. So first I'll show you the layout for this, that is a shuttering layout, and then we'll come to the slab reinforcement. So I'll just rotate this so that you'll understand. Yeah. So again, it's written here, second floor shuttering layout. Okay. When I say shuttering layout, I mean how your beams are gonna come and how your centering plates are gonna come and what is the size of the slab, that you'll get to understand, and the thickness of the slab. For example, let us say this particular slab. Okay, see, we'll be having beams all around. So this is one beam. Then I have one more beam at this point. Then there is one more beam at this particular point. And then there's one more beam at this particular point. So in between this, we are going to put the slab. So what is the thickness of this particular slab that is mentioned here? It has to be a 6-inch thick, which roughly comes to 150 mm. And then in the same way, you have one more slab here. The thickness is again 6 inches. So in this way, each and every slab, they are going to give you the thickness. Here also it is 6 inches. Now coming to this particular thing, it is X, like they have mentioned X here, they have mentioned X. X in the sense there may be a cutout. Cutout means the slab is not going to come. Or in this case, a lift is going to come here. And in this case, a staircase is coming here. Since the staircase and lift is coming, you will not have any slab at the second floor level, third floor level. Only at the roof level, you will be having a slab. Okay. So that is why in the second floor layout, they have shown a X mark here. Fine. Now going to the reinforcement part. So this is my reinforcement part. So again, if you are looking this drawing for the very first time, and if you don't have an exposure on the construction side, definitely it's not an easy thing for you to understand. To put it in a more better way, if you're really interested to learn all these things in a better way, my courses are available. I would definitely ask you to enroll in my courses where you can get a good amount of knowledge. But anyhow, since you're coming and watching my lectures, I'll just give you a brief idea about those things, because when I teach, I make sure I teach you completely from the construction side. Okay, this is how I teach in my entire course. But again, we all know there are two kinds of slab basically. One is called as a one-way slab, and the second one is called as a two-way slab. So why it is called one-way slab? Any slab which bends in one direction, we call that as a one-way slab. Any slab which bends in both the direction, then we call it as a two-way slab. Again, further one-way slab is further classified. So, but we'll not get into that. But this basic understanding, if you have, it's enough. Apart from that, the one more definition of one-way and two-way slab is that if Ly by Lx ratio, that is, if the span, if the longer direction divided by shorter direction, if it's greater than 2, we call it as a one-way slab. And if Ly by Lx, if your longer span divided by shorter span, if it is less or equal to 2, we call it as a two-way slab. To put it in a better way, you see this particular slab. Okay. So this is my direction here. Just 1 minute. So this is my shorter span. Just 1 minute. Yeah. This is my shorter span. Span is always from inner to inner, beam inner to beam inner. And this is my longer span. So when I divide the longer span, this longer span, when I divide it by shorter span, if that ratio is less or equal to 2, it will become a two-way slab. If it is greater than 2, it is a one-way slab. Definitely here the answer will be greater than 2. So definitely this particular slab, what I can see, it is a one-way slab. You getting my point? No? So this is how we are supposed to identify the slab. In the same way, I'll show you one more slab. I'll go to one more slab now. If you look at this particular slab, it's a two-way slab. Why it is two-way slab? Again, always remember, if any slab is square in shape, usually it is a two-way slab. If any slab is rectangular in shape, it is usually a one-way slab. That is how we usually identify. Yeah, but you can confirm that by Ly by Lx ratio. Again, if you see, this is my inner to inner distance. This is my shorter span, let us say, and this is my longer span. So if you divide the longer span with the shorter span, definitely this ratio will come less than 2, and it is a two-way slab. Okay, that is how you identify the one-way slab and two-way slab. Now if I go back to the drawing, how we will identify whether it's a one-way slab or two-way slab? So definitely through this drawing I can identify. Suppose if I take this particular slab, So my slab is coming in this direction. Okay, this is my slab. So what is the shape that I have? Definitely it's a kind of a square shape. So it's a two-way slab for me. So where is my one-way slab? Let me check if I can find any one-way slab here. So here I think almost everyone is like, square in shape. So definitely they all are your two-way slab only. So there is no one-way slab here. Yeah. Now how you will put the reinforcement? Again, it requires a good amount of understanding, but still I'll give you a basic idea how the reinforcements are supposed to be put, how to read it first. So always you have to start with the shorter span. So this is my shorter span, this is my shorter span, and this is my longer span. So the first bar is going to come in this direction. This will be my shorter span bar. I'll put my first bar in this direction. Once this bar is done, I'll put the longer span. This is my longer span. Okay, this is how we generally put. Okay, now coming to this particular drawing, see, we'll start the bar from here. Let us say, I'll start the bar like this, and I'll give you a small crank. Crank means it's a bend. I'll bend it like this, and I'll take it to the top. Got it? Next bar, what I'll do is I'll take a bar from this direction now. After that, next bar, I'll start from here, give a crank this side now, and take it continuously like this. Okay. Then again, I'm going to repeat the same thing. Again, next bar, I'll start from here, bring it up to distance. Here, give a small crank and take it to the top. Then again, you can see the black color, right? So again, I'll start from here, give a small crank and take it to the top like this. This is how I'm going to place the bar. Now, what is the diameter of the bar and what is the spacing between these two bars? This diameter, it is mentioned here. How you will understand? Just observe the drawing here. You can see this particular dot here is mentioning that T of 8. That means you're supposed to use a 8 diameter bar, and the distance between these two bar is how much? 5 inches center to center spacing. 5 inches is 125 mm. So in this way, you're supposed to keep the bar. So your shorter span is over. Now let me go to the longer span now. Now coming to the longer span, again, I'll follow the same pattern. Again, let me start the bar from here. Okay, there's small mistake from here. Okay, I'll start from here. I'll start from here. I'll take the bar. I'll give a crank here and I'll take it continuously like this. Okay. In the same way, I'll start from here, this side. I'll start from here, bring the bar up to here. Wait. I'll start from here, give a crank here and bring it like this. So in this way, I'm going to place the bar again. Again, what is the distance between this two bar and the diameter of the bar? It is mentioned here. You're supposed to use a 8 diameter bar. The distance between these two bar has to be 7 inches center to center spacing, which roughly comes to 175 mm center to center. This is how you're supposed to understand it. Now the question is why this crank bar and all are supposed to be provided. Again, there's a big topic behind that, which is explained in my course. See, I will not explain everything. I always told in my lecture. Some people may feel that he's not explaining. Definitely, I'll not explain everything because if I explain everything, nobody will listen to that. So I always suggest enroll in the course where you get a more clarity. But anyhow, I'll give a small understanding. So usually what happens when the load comes on your slab and all, no? Let me put it in a better way. So see, we have one beam here. I have one more beam here. I have one more beam here. Okay. In between this, we have a slab, right? We have a slab here. One slab here, and let's say another slab here. So you should know how the behavior is. So the behavior is that this particular area will experience a kind of a negative bending moment. The middle portion will experience a sagging bending moment. Since it's a continuous portion, that is this beam is supported out. Okay, now I'll finish it off. Then again, it will sag like this. Then again, it is going to have a negative bending moment like this. So if I draw one line in between them, I'll just draw one line between them like this. Okay. So we have a negative here. So negative means this portion is try to lift up. We have a positive here. This entire thing is negative, positive and negative. Got it? Fine. So when the load comes on this particular slab, due to your slab and the beam interaction, what will happen is this portion will try to lift up. This portion will try to sag. It will go down. Again, lift up, sag and go up. So based on that, we are going to give the reinforcement. Since it is trying to go up, I need to stop that. So what I give is I provide a top steel like this. Got it? Now this portion is trying to go down. So I'll be providing a bottom reinforcement like this. Again, this portion is trying to lift up. So I'll provide a top reinforcement here. Again, this portion is trying to sag down, that is positive bending moment. Again, I'll provide a bottom reinforcement. This portion is trying to go up, I'll provide a top reinforcement. This is a concept, this is a behavior of a slab and a beam. Based on the behavior, now if I explain you back why I'm providing a bar like this, it's a top bar. I'll give a crank and bring it down and I'll take it like this. Then here I'll give from bottom. Then I'll give a crank here. And you see this top bar, it is extended up to this portion. Why? Because we had a negative bending moment like this. I hope at least some basic knowledge you're able to get. Of course, everything in depth is explained in my course because I take more than 2 hours to explain all these things. That is why I always tell, because on YouTube, it's not possible to teach you. So whatever I've explained, practically I'll show it here so that you can will find interest in all these things. Now, if I ask you, can you correlate all these things? Exactly. See, I have a beam here. I have a beam here. I have a beam in this direction. I have a beam in this direction. And in between that, I have a slab. Now, if I ask you, draw the bending moment diagram of this, or if I ask you, show what is the bending moment of this. So this portion will try to lift up. It will try to go down, sagging, and a negative bending moment. So that is why you can see, the top steel has been provided here. If you see here, I'm providing a top steel like this. Wait. Let me do a white color. So you can see I'm providing a top steel like this. Here also it is trying to go up. I'm providing a top steel like this. Now here it is bottom reinforcement. So I mean it is trying to sag down. I need to provide bottom reinforcement. So the same bar I'll give a crank like this and take it like this. You're getting my point, no? So this is how you are supposed to do it. Again, there are different ways of doing. There are almost 5 types of slab reinforcement which you can give. I have explained you only for one. So practically when you enroll in my entire courses, there I'll teach you 5 types of reinforcement. One is alternate crank, that is both the side you will be providing a crank. Second, alternate crank is not both side, alternate crank. This is alternate crank. What is alternate crank? Just try have an understanding. Alternate crank means from here I'll start my bar like this. I'll give a crank like this, and this bar will go to the bottom. Next, I'll start a crank from this direction like this, and it will go down like this. So this is called as a alternate crank. There's one more pattern called as a both side crank. Both side crank is, okay, I'll show you image for that also, just to put it in a better way. This is called as both side crank. So both side crank, if you see, bar is coming from here. I give a crank here, brought it like this. Then again, here also I'll give a crank. I'll take it like this. The next bar will go straight again. Then again, I'll give crank from both the side. Again, concept remains the same, but different ways of giving the things. But nowadays, in most of the projects and all, we don't use crank bar and all. So what we are using is we're going for a cut reinforcement. So what is this cut reinforcement? This is cut reinforcement. There is no crank. Wherever top steel is given, required top steel will provide. Wherever bottom steel is required, will provide bottom steel. So this is called as a cut reinforcement. So again, you see all these things are cut reinforcement. All these things are cut reinforcement. Got it? So in this, totally there are 5 types of bar in the slab. So if you understood all the 5 bar, definitely you can go to any construction site. You'll never have any doubts in your life regarding the slab. Most of the students, most of the experienced people, what happens is they not understand the concept. So once you do, if you don't understand the concept, no, definitely even if you go and visit hundreds of construction site, hundreds of slab, you'll still have a confusion why they have given crank in that particular slab, why the crank is not given here, why they have given alternate crank in this building, why they have not given both side crank in this building. You'll have hundreds of confusion. So if you understand the concept, all this confusion will vanish. So that is what I do in my course, and that is why students are enrolling in my course and upgrading their knowledge. Got it? So this was all about the slab part. I think whatever knowledge is required, we explain you. Now, what all things you need to understand more? The understand is how this 2 feet 6 inches coming. Why it is 2 feet 6 inch only? Why this 4 feet is coming? From where it is coming? How the calculations you are supposed to do? So that is what I teach in my entire courses. So I'll give you one opportunity in case if you want to learn, you can learn it. No, I'm not forcing anyone. If you're really interested to upgrade your knowledge, this is the best platform. Under my training, you'll go to that level where people will take another 3 to 4 years to study on your own. So if you enroll in my you can start with my free course, not an issue. See how I teach. If you feel my content is good, I'm able to teach you in a better way. Definitely enroll in my construction manager mastery course, which has around 10-15% off on the entire course. That will be somewhere close to 8,500 rupees. So if you go to the content, I'll show you. I have course in both English and Hindi language. come to the English language. Level 1, level 2, level 3, level 4, level 5. In level 1, I teach you all the building execution from start to the end. There I'll teach you the structure drawing reading. What I'm teaching, the same building, G+3 residential building, I taught everything here. In this way, each and every lectures I've added. Right now, whatever I was teaching about the slab, the same thing I've explained here. Decoding the types of slab, decoding one-way slab, decoding one-way slab fundamentals, decoding two-way slab, decoding the slab reinforcement, complete floor structural drawings of a G+3 building. Got it? Only for one drawing I'm explaining. Here I'll explain you more than 20 plus drawings. So you can see even I have covered certain airport drawings and all. So lift wall reinforcement, foundation, raft foundation, high-rise building construction. You can see here high-rise building construction. Where is that? Okay, there is a 4 basement plus G plus 26 story. So in this, we will try to cover a lot of topics so that you will understand. Along with that, here I'll teach you how to place the column, how to prepare that beam layout, how to prepare the column sizes, what should be the column sizes, what should be the beam sizes, how to apply the load, how the analysis is done, how the values are extracted, how the column lateral tests are decided, how the beam detailing is done, how a one-way slab is designed, how a two-way slab is designed. Each and everything we are covering it here, so that whatever knowledge is needed. No, so this is how we try to teach in the entire course. Now coming to the big portion, that is about the reviews part. I always show the reviews so that you'll have a trust on my courses, and you will have a trust that whatever amount you are enrolling or whatever amount you are spending it in the right platform, and your money will give you 10x ka return. So he had enrolled in my construction manager mastery course, got placed as a fresher for a 4.2 lakh package. With one of my students got a package of 7 lakh. He was previously working. It's not a fresher, 7 lakh. He had around 6 months of experience, and he had enrolled in my construction manager mastery. Your course highly recommended. Okay. And then, of course, not these things are not. He is one of my student who got a job of around 4 lakh as a quantity survey. I'll go to few more reviews. Okay. This is already done. Best course till now. I went to various courses, but this is something next level thing you're going to learn heavily. I got a job abroad in my first interview. Now I'm in Saudi. Okay. And then again, just go through all these reviews so that you'll get an understanding. So I recently got placed as a diploma engineer trainee in KC International through your construction manager mastery course. And all these are the students enrolled in construction manager mastery course. Okay. And just go through a few of the reviews. And these are the students who were able to do the execution on the construction side through my online videos. This course is very helpful if you're a fresher. Okay. That's it. So in this way, I can show you thousands of reviews. But anyhow, our site engineers from contractor side need this course. I suggested them. Okay. This is the best course of my life. I got each and every doubts cleared. Okay. You can't find this kind of teaching anywhere. Okay. Again, all these other reviews. He's working in Dubai and all those things. He has recommended more than 50 plus people. I'm a site engineer. This course helped me immensely. Yeah, just that's it. So again, I can go on and go on. But again, I gave an interview on Saturday. Today I got selected and all. So this is the level of teaching what I do in my course, and that is what I teach in my course. Whatever you are seeing on YouTube is just a 1% of my teaching. So you can download my civilbrains app. If you trust me directly, I would suggest enroll in a construction manager mastery course. Whatever money you are investing, it will give you a 10x return. That is a promise from my side. But if you want to experience like how I teach, definitely, if you want to see how I teach on YouTube and in my course, enroll in my free course, watch it for 7 days. If you feel the content is good, there's a 10-15% off going on in my courses. Definitely enroll it and you'll go to a better position. That's it. Uh, I hope you have enjoyed my lecture up to here. Of course, I want to explain a lot of things, but again, on YouTube, people are not consistent. People will not spend so much of time. That is the reason I'm just restricting to only few topics. Otherwise, I can go on and explain you all these things. So, okay, anyhow, since you are watching it till the end, I'll give you one more one more information. See, this is one more type of slab reinforcement. It's a cut reinforcement. We are not using any crank bar here. So what we do is we will run half bar, then we'll run one full bar. Again, one half bar, or I can call it as a curtail bar, and then a full bar. Curtail bar, full bar. So in this way, this is another way of detailing what we do in the slab. Again, the concept remains the same. Now, what happens is wherever you are not running the bar here, what we can do is we can give a top bar. So we'll provide a top bar in this portion. So this top bar will take care of your negative bending moment. You're getting my point. So in this way, we have different ways of doing the things. But if you don't understand that negative bending moment ka concept, you will never understand all these things. End of the day, the concept remains the same. If you go to the construction site and if I ask you to draw the bending moment diagram, the first thing that should come in your mind is it is how you're supposed to draw a bending moment diagram. Like let me put it here. Okay, I'll put it here. Let's say, how shall I do? Okay, I'll take for this. I'll have a negative bending moment here. then it will be a sagging. Since it's a continuous portion, I'll have a negative, sagging, negative, sagging, negative, negative, sagging, negative, sagging. This is how the reinforcement, this is how the bending moment will be. Based on that only we are putting the reinforcement. Got it? That's it. So in this way, all these things will be covering in my courses so that you get, and all these courses are more than, 400, 500 hours. My entire drawing reading course is 30 hours. My entire site execution course is more than 70 plus hours. Quantity estimation course is 50 plus hours. So you can see all this reinforcement. This is how, and this is a drawing for that. Whatever I'm showing you, this is a drawing for all those things where I cover all this drawing. Now coming to the big question, sir, like I mentioned, how this is 2 feet 6 inch, why it is 4 feet, why it is 4 feet, why it is 4 feet 6 inch, from where it is coming. We have a code book for that. So this is a code book which you should understand. This is for the, yeah, which is this? This is for the beam portion. For the slab also we have. So here it will be mentioned, like from here you have to take 0.1. This extension has to be up to 0.3, 0. All this manual calculation you are supposed to do. Based on that, we are going to come to that conclusion till what distance I need to take my cut bars and all. Okay, that's it. So I hope you have enjoyed my lecture up to here, and I'll see you back in the next lecture. Thank you.